Hello and welcome back. So in this video, I'm going to introduce you to dynamic programming, something interviewers like to throw at you in an interview. And I got it experienced firsthand last month in my technical interview rounds for Microsoft. So what is dynamic programming? Dynamic programming is just overlapping subproblems and optimal substructures. And now this might not make sense, but just in a few seconds when we look into this, it will make sense. So what is overlapping subproblems? As we dive deep, it's nothing but a situation where past has information that can be reused. So past has information that can be reused during a program as the program executes. What is optimal substructure now? So it's when past information are optimized uh, and will be dynamically. So when past informations are optimized and will be dynamically done if needed. So if need be, um, as we move ahead in our program, in time in the program. So dynamic programming is just a method for solving problems which can be broken down into overlapping subproblems in problems where the past can be used to solve further to come up with a solution, and the past substructures that we broke can be optimized and are needed to be optimized. Theoretically, it is difficult to digest if you are looking into it for the first time, but let's just forget all about it for now as we proceed with further deep into dynamic programming. So within dynamic programming, we have two types of dynamic programming approaches. Tabulation, as I've written, it's a bottom-up approach. We start from 0 and go up to n, and the other approach is memoization approach, which is top-down approach. We'll see the difference between the two approach in a moment, but before that, in dynamic programming we always use lists or arrays. So in dynamic programming we have a DP, it's just a variable which is storing an array or a list. So let's say this is our array and we have the DP. In dynamic programming, generally we need to understand what is the state of this array at n. So there are two methods. In bottom up method, we start from dp0. We start from identifying what is 0 element, and then we proceed 1 2 3 till n, till we upwards till we obtain the nth element. So the aim is to obtain the nth element of dynamic programming. And in memoization top-down method, we start from n. We start from right what we need, its top, and we go downwards and optimize all the 0 1 2 3 elements. And once it's optimized, we always, in whichever method, we always return the dp at n. So starting from 0 or starting from n, you optimize all the elements in the array from 0 to n minus 1, and you obtain n from with the help of previously optimized elements in the array, and you return the last element of the array. So this is it, the dynamic programming. It's just a tabulation of elements, optimizing it using the previously optimized elements to further optimize the elements, saving time, and ultimately the end goal is to obtain the nth element. So now let's just quickly look into an example, and the most popular I have in my mind currently is Fibonacci. Fibonacci is nothing but every time the next element is the sum of the previous two elements. 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1, 3 plus 2 is 5, and so on. So dynamic programming and recursion are often linked quite closely. Recursion just leads to a wastage of lot of time, and dynamic programming saves that for us. So I'm now going to define a function fib which takes an input. It will return the nth element of the Fibonacci sequence. So if n equal to 0 or 1, I'm just going to return n, and it's the base condition or base case, because we need something to exit the loop, or else the recursion will happen infinitely. But since I use the word loop, recursion is closely linked with loop. We can always replace recursion with loop. So dynamic programming is closely related to recursion. Recursion and loop are the same thing, different approach. Recursion and loop leads to wastage of time because they do not store the past information, and dynamic programming saves that time, and in return it uses a lot more space, which is something we will look later. Space is not our concern. So we have returned Fibonacci n-1 plus Fibonacci n-2, and if Fibonacci 5 is we do, it will be return 4 plus 3, 4 plus 5 3, and fib 4 will be, it's just recursion. Basic recursion is gonna take place unless and until something is not returned. So Fibonacci 1 is the base case. If we have 1, it's going to return n. If n is equal to 1, 1 or 0, it's going to return n. So Fibonacci 2, again, the recursion will do in a stack order, stack fashion. And Fibonacci 0 will return 0 base case. Fibonacci 1 will return 1 base case. 2 is nothing plus 1 plus 0 now, so it will be 1. And Fibonacci 3 is nothing but 1 plus 1, so it will be 2. Fibonacci 2 is again, we will do the stack recursion over there. Fibonacci 2 is nothing but Fibonacci 1 plus Fibonacci 0. And now again we will go into the recursion deeper, and Fibonacci 0 will return 0 base case, 1 will return 1 base case. Fibonacci 2 now will be 1 plus 0, 2 plus 1, 3. Fibonacci 4 is 3, and the entire thing we did for finding the Fibonacci 3 will be as it is taking place in Fibonacci 3. And since Fibonacci 3 is 2, we have solved. We can directly assume that, and 3 plus 2 will be 5. So Fibonacci 5 will return 5. Now you can see that Fibonacci 3 and 3 had to repeat. So each time the Fibonacci 3 is encountered, the recursion has to retake place, and as the number of n input will increase, the number of encounters will increase, and the depth of required to solve each encounter will also increase, leading to wastage of time. So what if we could just do Fibonacci of 3 once and remember it somewhere, and if we see it again ever in the future, we can just see if we have seen it before, and if we have seen it before, we will just use it instead of again going into the recursion depth and wasting time. So that's the idea behind dynamic programming. So now I'm going to switch to my editor, where I'll demonstrate the dynamic programming approach in Python. So let's first see the tabulation bottom-up approach. So we have Fibonacci function def. I'm going to define a Fibonacci function fib, and I'll create an array and I'll name it as dp. So, and as we know that we will be iterating from 0th element in it to n element, so I'll define its size as n plus 1. I'll initialize the dp first element as 1, it's 1, and now I will iterate in a range from 0 to let's say 2 to range n plus 1. I am moving from bottom to up, and every time in the loop dpi will be dpi minus 1 plus dpi minus 2. That's the core definition of Fibonacci series. So now we'll just run a couple of test cases. Fibonacci 1, 2, 3, 4, then 5, even 6, 7, and now I'll just maximize the terminal, and you can see it's pretty much the order we had expected. The program is working fine. So we have now seen the tabulation method, and now let's move on to the memoization method, which is the top-down approach. Remember, in top-down approach, we are going to approach the DP from the top, that is n. Instead of here, we started from 0, initialized 1, and moved from 2 to n, towards n. Now we are going to pretty much start from the top. So I'll define an array outside the function, and in Python, the array is going to be global, so it can be accessed easily inside the function as well, no problem. So in the function, which is fibb, if n is equal to 0 or 1, I'm going to make the dp n equal to n, pretty much the base case. If dp n is none, which is if the n is first time approach, it will be n, it will be none. So if it's none, what we will do is replace it by Fibonacci n minus 1 plus Fibonacci n minus 2. So we are starting pretty much from n. If the user enters n as 7, we will not start from 0. Instead, we will start from 7, go all the way from 0, and then come back again to 7, and then output 7. So it was the top-down approach, and personally, I feel tabulation method very understandable, and somehow it feels quite simple, whereas on the other hand, the memoization doesn't feel natural to me. Actually, you'll see that tabulation is just the formation of an array, whereas the memoization is the recursion. So I'll just put down the recursion approach as well. So you can clearly see that memoization is quite the recursion approach, and we know that recursion and loop are the same thing, they can replace each other. So the tabulation is just, we are avoiding recursion, instead of we are building table from the very bottom. So that is it for dynamic programming, and next time we'll focus on solving problems that are standard and are asked in interviews. We'll start from easy and we'll move on to medium and even hard if. And the approach will be just like this video. We will start from whiteboard, decode and understand the approach, and then immediately we'll switch to the editor and end up programming the entire problem into a solution. Until then, goodbye, take care, and do subscribe so that we do meet next time as well. Thank you.